Hey, well, good day to you. That's right, we are the Ask Academy. On a smooth groove today, we're doing pre-calc. And in that pre-calc, we're going to be looking at specifically some things. We're analyzing the graphs. Yeah, that's right, graphs of functions. Graphs of functions are very vital and important. And we're going to learn in these next few days about that. So we're going to look at three things today of how to first find the domain and the range of a function if the graph of a function is given. And so what I'm going to do is provide you with vision. And let's see if we can do this with the video as we focus in on a specific graph. Again, we're going to find the domain and the range of a function. Finding the domain and range of a particular function as we look for that. But specifically what they're going to be doing for us is they're going to be giving us a picture. So if we're looking at the graph, we want to be able to analyze this, to be able to find the domain. Again, remembering that domain is the left and right values specific to the function it's given. If it stops at an endpoint, if it goes on for infinity. And we're going to be learning some notation that's called interval notation to be able to communicate that. Well, if we're just simply looking at the graph, it looks like the right and leftness, and we always go from left to right. We can see that the domain, the left and rightness, starts at -1, and then it ends at 2. And so, by the way, the closed dot means that we include that point there. And over here you see a dot that's not included. We're not going to include it there at 5. Sorry. So we start at the domain, or the x-coordinate of -1, and we move as far to the right as this function goes in our picture communicated to 5, but we're not going to include that. So how do we indicate that in function notation? What I want you to draw your attention to is that notation right there. And as we look at it, it says this is the domain that starts at -1. But we use this bracket to say, hey, we're including that. We're including that -1. Again, why? Because there at x -1, we had a closed circle, meaning we're including that point. Then the notation says, hey, we're going to go from 1 to 5. But notice they have a parenthesis on the 5 because in our graph we saw that there was an open circle there, meaning that we're approaching 5, getting ever closer to it, but we're not going to get there. So again, the domain, that's the notation now that we're going to use to communicate our domain. B is asking or showing us how to find the range as we're looking at the B response. Range again is the up and downness. It is the here they're showing us how to, and in the B portion they're asking us to find the value of a function at a certain point. So they say, again, we've already practiced that. We know the function f. We're just going to look and see what the value is when x, or the domain, is 1. We just simply look at that graph, find the value where x is 1, and see where the function is. How high is it? Well, it appears to be up at 1. So again, whatever that value is, they're going to ask us to look for. In the C portion, they're asking us to find the range. So what does that mean? Well, it means the up and downness of the graph, of the curve. So we're going to always start and go to bottom to top, and we're going to use, again, function notation, saying that we're starting at what value, range-wise? -3. And as we go up, that's the lowest value. As we go up, we go as far as we can to see, in this particular case, how far does the graph go. Well, here it goes to 3, there it goes to 2, and it looks like the highest range there is 3. So our interval notation, again, let's see how they write it. For the range, it starts at -3, but why did they use the bracket? Yeah, and why did they use the bracket on the 3? That's right. So that's how we're going to look at graphs, finding the domain and range. Hey. Second thing I want to show you is how to find zeros. And what they're going to do here is they're going to give you functions, and I'm actually going to write one out now that I don't have to look at the picture. I want us to be able to find the value of a function at when the function is 0. So let's see. So let's say we have a function let's say that our function starts out that way. And that particular function, we want to find what they call the 0. Well, the 0 would mean that on a vertical and horizontal axis, where on this 0, this x-axis, this ground, this is 0 height level of the function, what values of the domain of x do we find the 0? So what that means that you're going to do algebraically is you're going to set f of x equal to 0. And you're going to solve by x, solve for x. Now this we've studied functions like this. This is called quadratic because the degree is 2. And we've learned many techniques: quadratic formula, factoring, completing the squares. We're going to demonstrate factoring for you today because this particular one they've given you will factor. We need two things to multiply 3x squared. 3 is prime, so we really have only one of those choices. And then we have things that we need to multiply to 10. And then we're going to check our outer inner of our FOIL once we guess those, because a is not 1, it's 3. That leading coefficient is 3, not 1. But factoring is a little bit different. But still, I need numbers that multiply to 10. 3, 4, 5, that's it. Those are the numbers that multiply to 10. As I did off to the side, those are my factors. And so those are the options that I have. I'm going to guess. And I'm going to check outer inner of my FOIL. I'm going to check the outer inner of the FOIL. And so what I'm going to do is check the outer inner. Outer gets me 6x, inner gets me negative 10x. Sorry. Outer gets me 6x when I multiply. Inner gets me negative 5. 6x and 5x adds to the 1x that I want, so I know I have it factored correctly. And now I use the zero product rule that says when two things are being multiplied equal to 0, I set those two things to 0 and solve for x in each. This one, 3x is going to be 5, x is going to be 5 divided by 3. Solving for x in this one. Those are the two solutions that I get for zeros in that particular problem. Now they're going to give you other functions to solve for zeros. Algebraically, that's the steps. You're going to be factoring quadratics. You're going to be factoring out common terms. You're going to be factoring by grouping, and some of the skills that we've learned in previous courses in the factoring notion. Hey, we are the Ask Academy. Hey, don't forget, the way to get to where you want to go in life is strengthening your algebra skills. We'll see you next time. We are the Ask Academy.